Okay, I'm back. I had to take a little break, get a little drink of water, a little something to eat, and I hope that as you're watching these videos, if you feel your mind is adrift and you're unable to focus on the things that I say, that you just hit pause, get up, do a couple of jumping jacks, and then sit back down and refocus and go at it for another 5 or 10 minutes. Every once in a while, you just have to take a breath. So, what's next? What I would like to do down here is that I feel like I've got enough code in my maze generator, and I'm really feeling like that this class is more about the graphical interface, the buttons and the scroll bars and the labels. This is a container class that's just going to contain and hold information. And this class is more of the algorithm, the back end, the thing that does all the thinking and the calculation. Okay? That's kind of the architecture, the design of my program. And so at this point, I've got the interface basically done. The container doesn't, there's not really a whole lot to do there. It's just action performed. I've got a maze object. I just want to tell that maze object to generate a maze. I want to tell it how many rows and columns are in the maze, and then tell my JFrame to repaint and everything be done. So, maze dot generate maze. How many rows? Rows dot get value, right? The value of the scroll bar that controls how many rows, how many columns. Calls dot get value. The value of the scroll bar that controls how many columns. And then repaint. Now at this point, whoops, it'd be rows. At this point, Eclipse is complaining at me. It says that that maze object doesn't have a generate maze method. Okay. It says, oh, maze. It says, oh, I don't even have to, oh, I called it my maze. Okay, now it's complaining that it doesn't have a generate maze method. And it's asking me, hey, do you want to create a method generate maze that takes 2 ints inside of the maze class? Yeah, that's exactly what I want to do. So I'm going to click that, and boom, I'm no longer in the maze generator, I'm on the maze class. And it's got this new method that was automatically generated by Eclipse with the 2 parameters, val and val2. I don't like val and val2. I like rows and calls. Because that way I'll know what those variables hold. The rows and the columns, and the number of rows or the number of columns that are going to be in my maze. Now, I'm going to need some data when I generate a maze. Remember from Wikipedia, if I've still got it up, I don't still have it up. Not unless it's in Chrome. Oh, I do. No, yeah, I do. Add the walls of the cell to a list. Okay. Each wall is going to be a location, essentially. Add the location to the list. So I'm going to need to have a list of locations. And that list is going to grow and shrink. So in here, I'm going to have something like private array list of type location. Okay, so this array list is going to hold locations. And I'm going to call this possible locations. Because when I add a location to this, it'll be a possible location that might eventually become a passageway in my maze. Now, if I'm going to use array list, I have to import array list. Now, I'm going to use something else that I haven't used before. I'm going to use an array. So this is an array list. An array is a container class, and I'm going to use not just an array, but a two-dimensional array. So I'm going to say private int, two sets of square brackets, and I'm going to call this the maze. Okay? So think of this as a grid, okay? A grid of ints. So it's got rows, it's got columns, and in each cell of the grid, there is a number, okay? I'm going to set that number, actually, I might as well just make it Boolean, because I was going to set it to 1 or 0. That's the way I originally implemented it. But I'm just going to set it to Boolean. Boolean, true, if it is a passageway in the maze, and false if it's not, okay? Now, I'm also going to have private int rows and calls. That's going to be the number of rows and columns in the maze. And a private int width and height. Okay? That's the width and height of the J panel, the little area on my J frame where I'm allowed to draw. Now I set that in Maze Generator when I set the bounds. I set it to 500 by 500. But that was set over here in this class, and right now my maze doesn't conveniently know what that is. If I want to get the width and height, I need a dimension object, and I can get the dimension object for this J panel with a method called getSize. So I say dimension dim equals getSize. Of course, if I'm going to use a dimension object, I need to import dimension. And then I can say width equals getWidth. No, I'm sorry, dim.width. Height equals dim.height. The reason I'm setting these here, now normally all of my instance variables, any variables that I declare up top, would be initialized in the constructor. However, these variables, this array list of possible locations in this maze, I'm going to want to reset them every time I press the button on my maze generator. And so why bother setting them in the constructor if every time I generate my maze I just reset them to something new? Width and height don't always change. I guess I could have set them in the constructor, but this is just fine. This will work. What do I want to do next? I want to set the rows and columns. Now the variables passed in, rows and columns, these are local to this method. These two variables live and die between this bracket and this one. These two variables up here live and die between this bracket and this bracket. But there's an overlap. Both these variables and these variables live here. They're both in existence together for that short period of time, but they both have the same name. And I want to be able to distinguish between them. So in order to be able to access the variables up here, I have to use the keyword this. I'm going to say this dot rows equals rows, and this dot calls equals calls. That's the way I set the values of these up here that live a long time to the value that I got from outside, from the maze generator that were passed in. These variables only live for a short time, but I want to store the values for a longer period of time. Okay, this rows, this columns. I set the rows, I set the columns. What other values? The maze. Oh, and possible locations. So I've created the variable possible locations. I'm going to create the object. Okay, so this is declaring the variable. I got to create the object for it. Possible locations equals new array list of type location. Now that thing is empty. I've got a variable, the maze. I need to create the object. The maze equals new Boolean, and inside of square brackets I'm going to put rows calls. So that's a little different than an array list, isn't it? An array declared with these square brackets is a container that can hold multiple objects or multiple basic data types. Array list can only hold objects. It cannot hold basic data types. But the array list can grow and shrink. The array is a fixed size. So when I create it here, I have to tell it how many rows and how many columns. And so I'm going to create this array of fixed size of type Boolean. If I know ahead of time how big something is, how many items I'm going to store in my container, then it's probably better to store it in an array. But if I don't know ahead of time and I want it to be able to grow and shrink, it's probably better to put it in an array list. The array is more efficient, but it's less flexible. The computer will run much faster when using an array than when using an array list. But anything you can do with one, you can do with the other. It just might be a little harder with one than with the other. All right. What else do I need to do? I want to initialize my set of possible locations with one location that is going to be that seed point, the place that I'm going to start my maze. So I'm going to start that seed point at location 1, 1. I'm going to say possible locations dot add new location 1, 1. Okay, so when I create a location, oh, I don't have a constructor that takes 2 parameters, do I? I don't. It's given me a complaint. It says, you can create a constructor in the location class that takes 2 ints. Okay, that's what I want to do. I don't like where they put it. I like to always declare my variables up top, put the constructors below that, and then any methods below that. It's saying I and J. That's not the best names, but I'm just going to say, I like to say X and Y. And I'm going to say this dot X equals X, and this dot Y equals Y. It just assigns the values of those variables. we'll get at them later. Notice that I normally make my instance variables private. But in a container class like this, that all I can do is create it and then access the data, I'm going to make them public. It's a very simple class. These two are public. They could be private, I suppose. But if something is final, that means it can't change. It'll never change. It'll never be on the left side of an equal sign outside of the constructor or the declaration. So you declare it as having a certain value, and then you never change the value anywhere else in your code if it's final. It is very common to make final variables also public and static. We've used a public static final variable when we said scroll bar dot vertical. That's a public static final variable that's inside of scroll bar. Sometimes it's convenient to have those. They're often referred to as constants. It's the way to give a name to something that is a value that you'd like to reference later. All right, so I create a new location. And in my algorithm that I got from Wikipedia, it said as long as there are locations in the list, right? So that's what I'm going to do. I'm going to say while possible locations.size is greater than 0. Okay, so this kind of loop, I know we've done for loops and for each loops. I don't remember whether we've talked about while loops. The way a while loop works is that you've got the word while, you've got round brackets, and then you've got some expression that evaluates to true or false. It evaluates the expression, and if that expression is true, it does the stuff inside the squiggly brackets. And then it evaluates the expression again, and if the expression is still true, it does the stuff in the squiggly brackets again. And it keeps doing this stuff in the squiggly brackets over and over and over again until the expression becomes false, and then it gets out of the loop. Okay. I'm going to say int I. Now what I'd like to do is I'd like to pick a location out of that list at random. Because right now it's only got one. But at some point it's going to have more than one. So int I equals int math.random times possible locations dot size Okay. Now, if this possible locations, if that size is 5, this evaluates to 5. 5 times some number between 0 and 1 is going to give me a number between 0 and 5. Except that math.random never gives me a value that's quite 1. It's always something slightly less than 1. And so I'll never get quite 5. It might be 4.99999, whatever. When I cast that or convert it to an int, if the size was 5, I would get a 0, 1, 2, 3, or 4. Now, a valid index into an array. The first index, the index of the first element, is 0. The next one is 1, 2, 3, 4. If it's got 5 elements in it, the biggest valid index is 4. So this little expression, math.random times possible locations.size, casted to an int, is going to give me some number at random, which is a valid index into that array list. And I can use it to get a random thing out of the array list. So now I want to get that location out. So I'm going to say location loc is equal to possible locations dot remove I. So I've removed that thing from the list, and I've got it. Now, if I'm going to make a method, check location. I'm going to give it a location, and if that method returns true, then I'm going to call the method add location. Essentially, I'm going to check and see, hey, is this a good location to add as a new passageway in my maze? And if it is, I'm going to add it. Except that checking it and adding it are not so trivial as to just, So I'm going to make those methods, I'm going to write them separately because that logic is a little bit complicated. So I'm going to say private. These are helper methods. Private Boolean check location. It's going to receive a location. We'll call it L. Okay. The job of check location is to check to see if this location is valid. Right now, I'm just going to write this as a stub. I'm going to say return true. All locations are valid. Somehow I got an extra squiggly bracket. I'm going to get rid of it. Now I don't have an add location method. So I'm going to create a stub for that. This one is going to be public void add location L. Now, how am I going to add a location to my grid? And how am I going to paint my grid? This is, I basically set up the framework for my thing, but I've still got a lot of work to do. I've got to be able to paint this maze once I've created it. I need to be able to check and see whether a new location is valid for a passage, and then I need to be able to add that passage. And you remember from the algorithm, when I added a passage, I also added its neighbors as possible locations to my array, to my list. I'm going to pause the video for a second. I need another little break. Okay, so one of the things that's been bothering me a little bit is that I don't have anything in here for paint component yet. And I'd like to, if possible, be able to paint my maze even before it's exactly finished and be able to see if this other code that I'm writing is correct or not. I know it is because I'd kind of tested it, but I hadn't really implemented it in exactly the order that I'm showing you. And I'd like to show you in pieces by pieces, compiling and running things rather than just typing in all of the code and then hitting run and saying, hey, look, it's magic, it all works. So there are a couple of things that I have to be careful about. And one is this seg fault or null pointer reference. I'm going to do things with this graphics object, but sometimes for strange reasons this thing gets called with null instead of an actual graphics object. And if that happens and I try to type something like g.setColor, and if G is just null, okay, which is just, it's an address to nothing, I can't set the color of that nothing, and my program will crash. So in order to prevent that crash, I'm just going to say if G equals null, return. And that's what's called defensive programming. It just makes sure that, because I don't know when this gets called or what's calling it. I just know that just magically when it needs to get called, it gets called, and my component paints itself on the screen. But sometimes it gets called with null for some strange reason that I don't really know. The other thing is, it may get called before I've actually created a maze. Okay, and if that happens, the maze is null. And I'm going to use this variable to figure out which cells in my maze ought to be black and which ones ought to be white. So I'm just going to say if the maze is null, return. That's going to happen if I haven't generated my maze yet, if they haven't clicked the button yet. If paint gets called before they click the button, this paint method needs to just sort of quit and not draw anything, because I've got a maze to paint. Now, assuming I get down here, I just want to clear the screen, make it black. So I'm going to say g.setColor color.black. And this is just going to give me a black background. G.fillRect from 0, 0, and I can use width and height. That's the width and height of my panel. I set those when I generated my maze, and I know I've generated my maze because it's not null. Now, I'm going to put this double, calculate a double dx, and it's going to be my width divided by calls. Width is the total width. Calls is the number of columns. Now, if I type int here, dx, this is going to do what's called integer arithmetic, because both the numerator and denominator of the division are ints. In Java, when it sees an int in the top and an int in the bottom, it does the division and gives me back an int, a whole number. Now, I want to be a little bit careful here, because I may not want a whole number. It's throwing away information. If this is, say, 500 and this is, say, 7, 7 doesn't go into 500. I've got a decimal there. It's going to throw it away. I don't really want to throw that away yet, so I'm going to store it in a double. But if I do it that way, it does the integer arithmetic and throws it away before it does the storage, before it stores it in the variable. So I've already lost it before I even get it into the variable. So how do I force it to do double arithmetic and not throw away that decimal? I'm going to do a cast to a double. Now what this does is it converts the numerator to a double. And when one of the two, either the numerator or the denominator, doesn't matter which one, is got a decimal point in it, as a double, then it will promote the other one in the division to a double also, and do the division without throwing away the decimal. So that's what I want. Double dy is equal to, I'm going to cast to a double, the height and the rows. The height divided by the rows. Okay. So if I have this many, this is how wide my panel is, and this is the number of columns. This dx is the width of a single cell in my grid, and this is dy is the height of a single cell in my grid. Now for int row equals 0, row less than rows, row plus plus. I'm just going to walk through all my rows in the array, and for each row I'm going to walk through the columns. For int call equals 0, call less than calls, call plus plus. Okay, so I'm walking through my rows and I'm walking through my columns. Oh, before I do this, I want to set my color to white. Because I want my passageways. I'm about to draw my passageways. I've just filled in the background, and I'm going to draw these white passageways on that black background. And so now I can say if the maze sub row call, then g dot fill rect, and this is a bit tricky. I know the width and height. The width is going to be dx, the height is going to be dy. But what's my location? I know which row I'm in, I know what column I'm in. If I know the width, it's going to be the row, my x is going to be, my x is going to be the column times dx. And my y value is going to be the row times dy. And this is underlined. It doesn't like that because all of these have to be ints. So I'm going to cast this to an int. But I have to be careful. I want to cast after I do my multiplication. Dx is a double. If I cast before the multiplication, what I get is casting a call, which is already an int, to an int, and then when it multiplies, it promotes it back to a double. That's no good. So I put parentheses around. The other thing I don't want to do is I don't want to put the cast on this thing, dx, because if I cast it to an int ahead of time, I throw away the information too early. That rounding error will then get multiplied by the number of columns that I have, and I get a lot of rounding error. The whole point of having a double here is to have as little rounding error as possible. So I want to put off that cast as long as I possibly can to the latest point possible. I want to store my information in a double as long as I possibly can and not cast it to an int until the last possible moment. And that way I have less rounding error. Okay, and I'm going to do the same thing over here. I cast row times dy to call an int. And that should get rid of dx and dy. Those have to be cast to ints as well. Got it. Convert everything to ints. Now, let's see what happens if we just run this. Okay, so when I generate the maze, I get a big black spot because I don't have any passageways, so it doesn't draw any white squares. I want to see what happens if I just make it all white squares. I just want to see that I'm drawing stuff correctly here. So if I'm going to go through, what's the best way to do this? Well, let's just say if true. Okay, that's just going to always do this. That's just a quick way to debug things. Looks like it's working. Oh, I get some vertical lines. Why? Well, what's happening is that I lose some information here, and I lose a little information here. Sometimes this position, when, how do I say this? I've got a cell. Sometimes those cells are adjacent, and sometimes I end up with a 1 pixel gap between them. It does have to do with the rounding error. And it's when that rounding error of multiplying this float by some number of columns adds up to more, well, that's not a rounding error, it adds up to more than a pixel. And then this is just not quite enough to cover it. See, at first I just get a little rounding error, and the space is just exactly dx up until a point where that part of the decimal point that I'm throwing away becomes big enough that it gives me just one more than dx, and then I get a black line. I can fix that. I'm just going to say dx plus 1 and dy plus 1. That makes my passageways just a little bit bigger. Some of them will overlap, oh so slightly, but that's okay, because it won't be noticeable. It's better to have them overlap, the passages overlap just slightly, than to have a gap and end up with a strange looking line. And that'll work. All right. So I think I've got my paint component method done. I've got my generate maze method done. I got to do this check locations and add locations, and that's going to be a little bit hard. All right, so check locations. So when I check a location, what I'd like to do, I'm just going to get the int x and y values out of that location. Int x equals L dot x, int y equals L dot y. Now I'm going to create an array list. I'm going to look at all the neighbors to that location. Okay, I'm going to look all the way around it. Let me just write some comments here. I want to store all the neighbors that are already in the maze. Now, so a neighbor to a passageway. So if I think of a grid, let me just draw in paint a little bit. Forgive my messiness here. So say I'm looking at this cell right here. Its neighbors there are 8 neighbors, one above, one below, one to the left, one to the right, and then the 4 diagonals. Okay? It's the 4 cells around this thing. Now, if it happens to be in the corner of my grid, the neighbors above and to the left, they're not really in the maze at all. But I've still got these 3 neighbors. So I want to store all the neighbors that are already passages in the maze. If only one is in the maze, then it's okay to add this passage. If only two and they are adjacent, then it's still okay. If only three and all are in the same row or column, then still okay. Otherwise, don't add this location to the maze. All right, so this would be a return false. All right. So store all the neighbors that are already passages in the maze. So I'm going to create an array list of locations. Array list of type location. I'm going to call it taken because it's all the neighbors to the location L that are already in the maze that are taken. They're taken as passages. Okay? So that variable taken, which is an array list of type location, is going to hold some new array list of location. So each time this check location method is called, it's going to create a brand new empty array list of locations, and it's going to add a bunch to it. Now I'm going to make a method check maze. I can make it private. It's going to get an int x and an int y. It'll return true if x and y are in the maze. Okay, I'm going to make add location private too. It doesn't need to be public. And there's a general rule. If it can be private, it should be private. There's a general rule. It's a good general rule. Now, if a location is outside the maze, it's not in the maze. Okay, so check maze should return false if x is less than 0, or if y is less than 0, or if x is greater than or equal to the number of rows, or greater than or equal to the number of columns. Remember, if x is equal to the number of rows, it's still an invalid index into the maze, yeah? So, if x is less than 0, or y is less than 0, or x is less than or equal to rows, is greater than or equal to rows, x greater than or equal to cols. You got to be careful here. Or y is greater than or equal to rows. Return false. Okay? Now, what else? Now, if it's not out of bounds, then I want to return true if what? if actually, I'm not going to call it check maze. That's not the best name for this method. I'm going to call it is available. Okay, a location is not available in the maze if it's outside the maze. It's not available if it's already a passage, right? So then I can return the maze. Now, if this is rows and this is columns, then rows, if I want to know what row it's in, that's the Y and then the X. That's important. Y first and then the X. Return the maze sub Y sub X. And it's true if it's a passage, right? But it's only available if it's not a passage. So I want to, so the maze sub yx will be true if the location yx is a passage. And it's only available if it's not a passage. So I put a not in front of there. So the reason I wrote is available is because I wanted to tie this bounds check in. And I'm going to do this like 8 times, and I didn't want to have to retype that or copy paste it 8 times. So this is a short little method that's just going to help me out here a little bit. So I'm going to say something like if check maze. And I need an x and a y, right? I want to say x minus 1, y minus 1. So if I've got location L and xy is the location of L, x minus 1, y minus 1. So if this is L, x minus 1, y minus 1 is this location up there. Okay. So if that returns true, it's available, right? Oh, hang on a second. Is available. Let me think about this for a second. I'm going to change this to not available. How about is available? Sometimes it's hard to choose a good name for a method to make it kind of intuitive. Let's see. So if it is available, then it can't be taken. So if it's not available, then taken dot add new location x minus 1, y minus 1. Okay, and I just want to do this 8 times, once for each method. Now, the way I'm copy pasting here, I'm using my arrow keys to do it really fast. I'm going to do that again. I'm going to put my cursor at the beginning of a line. I'm going to hold down the shift key and tap the down arrow to highlight a line, and I can highlight as many lines as I want. And then I'm going to hold down the control and tap the C key. And then I use the down arrow and up arrow so that I've just got my cursor at the very next line. I'm going to hold down control V and go 1, 2, 3, 4, 5, 6, 7. So if I've just had 1 and I've made 7 new copies, I now have that 8 times. And once for each of the neighbors. So I'm going to have for each y minus 1, okay, so y minus 1 is the row above. I've got an x minus 1, an x, and an x plus 1. So I'm going to say x minus 1, x and x plus 1. That takes care of the top row. That takes care of that one, and that one. Now for each x plus 1, I've got or each y plus 1, I've got the same thing. So I've did those three. I'm going to do these three. Y plus 1. This is the row below. The row above and the row below. And here it's going to be x minus 1, x, and x plus 1. And now I want, so I've done this one, and that one. Whoops, no. I've done that one, and that one. Now I want the one to the left and to the right. So to the left, the y, to the left and right, it's just going to be y. It's going to be an x minus 1 and an x plus 1. Now I've got to make sure that these over here are the same as those over there. I'm just going to copy paste. So I highlight it, Control C, highlight it, Control V. This may not be the fastest way, it may not be the best way, but it'll work, and it doesn't take quite all that long. Now this is really important to be kind of careful with these. If you get these numbers wrong, and there's quite a few of them to type, so be careful and look them over a second time before you go on to the next step, because if you mess up on even one of these, it's just going to mess up your program and it won't work. If you put a minus where there should be a plus, or plus where there should be a minus, or you leave off the minus 1 or plus 1, and if the left hand side is different from the right, or if you do something twice, or if there's one of these that's not done, it'll just blow everything out of the water, and none of it's going to work. So be really careful, just meticulous about these lines. It's not hard, it's just hard to be tedious and careful, and oh, I shouldn't say tedious, to be meticulous. To be meticulous is a valuable skill to get things right. Okay, so if only one is in the maze, then it's okay to add this to the passage. So if taken dot size equals 1, return true. If only 2 and they are adjacent, if taken dot size equals 2 and are adjacent. Okay, I'm going to say are adjacent. I'm going to make another method, helper method. If the taken locations are adjacent, return true. Okay, it's complaining because I don't have an are adjacent method, so create method are adjacent. And it's added a private Boolean are adjacent array list of methods taken return, and it's created a stub for return false. All right, homework for you. Are adjacent. Here's the idea. Calculate the distance between them. If that distance is 1, return true. otherwise return false. That's not too hard, right? You got two locations with x and y values. Just calculate the distance between them. If it is exactly 1, they must be neighbors. There's no other way for them to be neighbors than for it to be 1. They are neighbors if their distance, if the distance between the two locations is exactly 1. All right. I'll add one little thing for you. Location 1 equals taken.get 0. That gets one location out of the array list. And location 2 equals taken.get 1. Now, if you want the x value of 1, you just type in 1.x of the first location. Actually, let me call it first and second. Okay. If you want the y value of the first location, it's x dot, or okay, the x value of the first location is first.x. The y value of the first location is first.y. The x value of the second location is second.x. The y value of the second location is second.y. And you know the distance formula, I think. I think we had that as a previous assignment. So this is just a slight variation of the distance formula. I find that when I program, the distance formula comes up over and over and over again. Just slight variations. I've always got to do slight variations on it. There's so many applications that just, you got to learn how to do different variations of the distance formula if you're going to be a halfway decent programmer to solve any kind of real-world problem. So, if taken.size equals 3 and are in same row or call. Taken. So if we've taken 3 and they're all in the same row or column, return true. Okay, so say I've got some location and I've identified taken locations. If they're all in the same row, if there are only 3, exactly 3 that are taken, they're all in the same row, then they have to all either be up here or all down here. If they're all in the same column, they all have to be over here or over here. If that's the case, then this passage is not going to connect to existing passageways. That's the basic idea. Is when I add a passage, I want to make sure that my new passage isn't connecting to existing passageways. Otherwise, it's going to create a loop in my maze, and I don't get a good maze. I'm going to ask you to also complete this method, and these are the only 2 methods that I'm going to ask you to complete. I'm going to show you what the program does in the video, and then you'll know you got it right if your program creates a maze like mine does. And really, if your program creates a maze, if you find some other way of doing it, and you can generate mazes, then you get full credit. Now, I would prefer if you just, I think you're going to find it easiest if you just complete the 2 methods that I give you to complete. But okay, so I'm going to come up here. It's going to say create method are in the same row or column. So I'm gonna get a location first, second, and third. So it's going to look like this. I highlight these 2, copy and paste. I'm going to copy this one and call this third. And get 2. Now, if the x values are all the same, or if the y values are all the same, return true. Otherwise, return false. That shouldn't be too bad. I'm going to stop this video, and then I'm going to finish in a third video.